So obviously, this function has or has not, this function has or does not have critical numbers. What do you think? And if it does, where are they? I'm gonna go slowly and you say stop where you see a critical number. Exactly. Where does it come from?
F means 0.
Yes.
Another one.
Another one. From the same source, still f prime being 0. I'm showing the slope. The slope is f prime. The slope of the tangent, right? Now, we found two critical numbers, this point and this point, or this, I should say, value. Look what happens here. The function does what?
It's coming down.
Yes, decreases. Very good.
Then it starts to increase.
Increasing, and then?
Decrease.
Good. So when we say the function is decreasing, what type of tangent, what type of slope does the tangent have here?
A negative one?
Yes. The slope of the tangent line is negative, meaning the first derivative is negative. Same thing here. So the slope here, all the way, the derivative is negative. When the derivative is negative, the function is decreasing. When the function is decreasing, the derivative is negative. What happens between these two critical numbers? What can you say about the function between these two?
It increases.
Yes, which means the first derivative is positive. The slope of the tangent line is positive. So this is a critical number that turns into what? So we have negative, 0 for this. So the derivative is negative, the derivative is 0, and the derivative is positive. This is a typical situation for a critical number that turns into what?
Would it be a minimum?
Exactly. There is another option. Negative, undefined positive. Something like this. Negative, undefined because it's a corner, positive. This is also a minimum. Because this comes from this source, and this comes from this source. So the possibility with f prime being 0, and the possibility with f prime being undefined. Both sequences, negative, 0, positive, negative, undefined, positive, will give us a minimum. Let's analyze this. It's positive, 0, negative, or positive, undefined, negative. What is this typical of? Positive, 0, negative. Positive, undefined, negative. What is this typical of? This particular sequence, no other.
Would it be a maximum?
A maximum. We call these relative or local. Relative min, relative max, local min, local max. Choose the one you like. I may use both of them. They mean the same thing. We use them interchangeably. So when we say a relative min, we say this situation where I can show that the function exists on both sides. If the function does not exist on both sides, we cannot call them relative or local. I'll give an example in a moment. Relative max or local max, the function must exist on both sides. This is a relative minimum, typical of this situation. This is a relative maximum, typical of this situation. And the function exists on both sides. And now we can look at this graph that they started with. I can't start with that. I have to explain the critical numbers first and then look at max min. Okay. So let's say, let's look at problem, you choose, it doesn't matter to me. And then we will look at how to determine critical numbers and how to analyze whether they are max or min. Okay, I will choose 3. So they want us to identify critical numbers or values. Good. Relative max, relative min, relative minimum points, and relative maximum points. Okay. So let's look at 3. Can anyone give us a critical number for number 3? X equals
X equals 2.
Yes, that's one of them. X equals 2. And is there anything else?
I would say -2.
Correct. Perfect. So here is the function. I will stop sharing in 1 second. And I will come back for reading other things in there. So you said right here perfectly a critical number, and you said right here a critical number. Perfect pick. My question is, where is this coming from, and where is this coming from?
The one from 2 is undefined, and -2 is 0.
Yes. So this is at -2, and this is at 2. Awesome. Now, see what happens? Up, 0, negative. Up, 0, negative. Positive, 0, negative for the slope. So then this point, -2 comma, and we have to read from the graph. -2 comma what?
-1.
Yes. -2 comma -1 is a relative
Max.
That's it. Awesome. Now let's go back to the other one. 2 comma
-3.
yes. 2 comma -3 is a relative or local, whichever you want to you prefer. It doesn't matter to me. Relative min. Relative min. Now, relative max is when x is -2. The actual max is -1. This is the location, and this is the actual. What is the location? When x is -2. How much is it? -1. This one. Where is it? At x equals 2. How much is it? -3. Now, notice another very important thing. When the derivative is positive, the function is increasing when the derivative is positive. The derivative is positive, the slope of the tangent line is positive, the function is increasing. How will I write that? From -infinity to -2, union from 2 to infinity. What is the interval of increasing? Interval on which f is increasing. -infinity, -2. We do not use brackets for intervals of increasing or decreasing. Everything is parentheses. Union 2 to infinity. When the derivative or the slope of the tangent line is negative, interval on which f is decreasing, no brackets, -2 to 2. So from the first derivative, f prime gives a lot of information about the function, about f of x. A lot. Number one, critical numbers. Number two, max min. Number three, increasing, decreasing. Intervals. So, critical numbers. Increasing, decreasing. Max, min. So this is what we learn. Studying the first derivative, we learn critical numbers, we know where the function has a max, min, and we know where the function is increasing or decreasing. And where's my phone? Only my phone tells the correct time. Yes, I have 3 minutes. So I would like to choose a very simple function and just find critical numbers. Okay, so I'm just going to start with 17. I'll stop in 3 minutes, I promise. So it's 17. We have f of x equals x squared plus x plus 2. You can say, I know this is quadratic. Why are you even picking that? A simple function for 2 minutes. So we are asked to find critical numbers. Critical numbers come from two sources. No matter what I do, I have to find the derivative. I can start with anything. I can analyze anything before I find the derivative. Can anyone give us the derivative of this function?
(2x plus y).
Very good. Then I have part A, where I write f prime of x equals 0, and I have part B, when I write f prime of x equals undefined. This is linear. There is no point in even discussing this situation for this particular function. I have to keep that in mind, but not for this one. Good. So when I set it equal to 0, I have 2x plus 1 equals 0. I move 1, it becomes negative, and I divide by 2. This is the critical number, the only critical number of this function. Is it a max or a min? Well, I know what it is because we know quadratics, but let's say we don't know. This is how we analyze it. In a table in which we have f prime of x, and then we have f of x. The domain of the function is quadratic, so it's everything. The critical number is -1/2. I have to put 0 underneath because that's where it's coming from. And then I have to study the sign left and right. So please look at this function, and let's say plug in -10. I'm not going to even put in the table. Plug in -10 here and just tell me the sign. I only want the sign. When you plug in -10, what will the sign be?
Negative.
That's it. When you plug in +10, what will the sign be?
Positive.
Yes. Which situation is this typical of? Negative, 0, positive. Negative, negative, 0, positive.
It's a min.
It's a min. Of course, a relative min. What is it? I have to plug it in the function. So the relative minimum will be f of -1/2.